So in this part, we are going to talk about a reaction that gives us the ability to add carbons to our starting material. So for example, if you have an alkyne such as butane, which has 4 carbons, and you want to convert that to a 7 or 8 carbon chain, you need to focus on this reaction, which we call that alkylation of terminal alkynes. So we are going to form basically a longer chain of hydrocarbons. Now, if you remember from preparation of alkynes, sodium amide was a strong enough base to deprotonate the terminal alkyne. So basically, amide will attack the proton and pushes the bonding electron over carbon to form the alkynyde ion. Now, this alkynyde ion is a powerful synthetic tool that we can use for alkylation purposes. Now, alkynyde ion, it has a lone pair of electrons on it, so it can act as a good source of electrons, so it can act as a nucleophile. So this is the nucleophile that we have. Now, nucleophile is looking for the electrophile. So a good electrophile that we talked about it before is alkyl halide. So alkyl halide can act as a good electrophile, and then the alkynyde ion can attack the electrophilic center and kicks off the leaving group to form a longer chain of hydrocarbon. Now let's look at the example. So in the first step, we are adding sodium amide, and in the second step, we are adding ethyl bromide. So the product for this reaction would be this structure. Now let's look at the mechanism to see how we got this product. So in the first step of this mechanism, amide will act as a base and takes the proton. So the first step is a proton transfer step to form the alkynyde ion. Okay, then in the next step, we are going to add alkyl halide. So the alkynyde ion, it has lone pair of electrons. It's a source of electrons, so it is our nucleophile. And we know that in alkyl halide, the alpha carbon can act as electrophile. So the alkynyde will attack the alpha carbon and kicks off the leaving group. So we are going to form this product. Now, in order to not miss the carbons, so I suggest you to number all the carbons. This is carbon 1, 2, 3, 4. So this is 1, 2, 3, 4. And then alkyl halide has 2 carbons. So this is carbon 5 and 6. And this is the new bond between carbon 4 and carbon 5. Now this process, the second step of this reaction, is happening through SN2 mechanism. And whatever we talked about SN2 mechanism can be applied here, meaning that this reaction is happening faster with the primary substrate comparing to secondary and tertiary substrate. So SN2 reaction is faster with the primary substrate. Now we can also install two different alkyl groups if the starting material is acetylene. So we talked about it before. Acetylene is the smallest alkyne and it has two acidic protons. So basically this reaction can happen 2 times on acetylene. So if you look at the specific example here, in the first step, we are using sodium amide. In the second step, we are using ethyl iodide. Again, in the third step, we can use sodium amide. And the fourth step, we are using another type of alkyl halide. So what's happening here? So in the first step, sodium amide will take the proton to form the alkyl ion. Okay. Then in the second step, you are going to add ethyl iodide, which has this structure. So this is the alpha carbon. Alkyl ion will attack the alpha carbon and kicks off the leaving group. So we are going to form this structure. So let's number the carbons. This is 1 and 2, 1 and 2. Again, in the third step, we are going to use another equivalent of sodium amide. So amide will take this proton and forms the alkyl ion in the other part of this structure. And then in the last step, we are gonna add this alkyl halide. So this is my alpha carbon. Okay. Alkyl attacks the alpha carbon and kicks off the leaving group. So let's number the carbons. This is carbon 1, 2, 3, 4, and 5. So we are going to form so carbon 1, 2, 3, 4, and 5. So let's number all the carbons. This is carbon 1, 2, 3, 4, and 5. And these are the carbons from the previous step. So this is the final structure that we can have. So let's redraw it nicely. So we are going to form this structure. Okay, again, this is 1, 2. This one is 1, 2, 3, 4, and 5.